Alright, we're going to do our first YouTube video of our geometry year. Next week, instead of having class, I'm going to be doing 4 YouTube videos or 5 YouTube videos of Chapter 8. So this is like a practice one. It's really awkward teaching these to talking to nobody, but I'm going to try. This is lesson 7. You might have already done this one or tried it. I'm going to try to explain. I'm going to explain the theorems in the chapter. So this is chapter 6, lesson 7. This is 2 more ways to prove triangle congruencies. So far, to prove 2 triangles are congruent, which means they have exactly the same shape, is using side angle side, and it has to be the included angle. You have to make sure the angle is in between 2 sides, and angle side angle, where it includes the side between 2 angles. And then our third way that we learned to prove congruent triangles was side, side, side. Today we're going to do 2 more different triangle congruencies. One new one is Theorem 30, and it's the angle, angle, side theorem. So this one says, if 2 angles and the side opposite of them, this should be and the side opposite of one of them in one triangle are equal to the corresponding parts of another triangle, then the triangles are congruent. So let's look at this one. Here we have 2 triangles. Hopefully I copied that right. Yeah. Here we have 2 triangles, and we have an angle, and a side congruent to an angle, angle, side of a second one. We're going to prove that these 2 triangles are congruent. So we'll just do a really informal proof. We're going to do informal proofs on both of these. So what we are given is we're given triangle ABC, and we're given triangle DEF. And it says in our theorem that if 2 angles in one side in one triangle are congruent to are equal to the corresponding parts in another triangle, then the triangles are congruent. So I have them marked up. So if angle A is equal to angle D, angle B is equal to angle E, and then our side, you'll notice that it doesn't say ASA because the side's not included in between the angles. So it's angle, angle, side in that order. It could have been this side equal to this side. So we have this side equal to this side. That's what we're given. Our job is to prove that triangle ABC is congruent to triangle DEF. We have angle, angle. Okay, we can say that angle C is equal to angle F because if we have 2 angles in one triangle equal to 2 angles in the second triangle, then we know that their third angles are equal. Because if you think about it, if this one plus this one adds up to, say, 120, then we know that this one has to be 60. And if these add up to 120, then this one also has to be 60. So we had that theorem before. Now we have, if you look at our triangles, we have angle, side, angle, angle, side, angle. So we know these 2 triangles are congruent by angle, side, angle. Now that one was an easy one. That's not much different than your side, angle, side, angle, side, angle, or side, side, side. But this next one is a lot different. This is a new one, number 2. This is Theorem 31, and this only works in right triangles. The other one, side, angle, side, 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 and angle, angle, side, they work in any triangles. But this particular one, Theorem 31, the hypotenuse and leg, that's what the H and L stand for. The hypotenuse leg congruence theorem only works for right triangles. This one says, if the hypotenuse, this is the hypotenuse, right? Opposite the right angle. If the hypotenuse and leg of one triangle are equal to the corresponding parts of another, and this should be right triangle, not just any triangle, right triangle, then the triangles are congruent. So here I have 2 triangles. And this proof's a little bit harder to understand, but I think it's important that we try it so that you can understand how to do these more difficult proofs. We don't always have time in class to do these, but we do on YouTube videos. So we're given triangle ABC is a right triangle, and triangle DEF, also right triangle. We're given there are right triangles, with the right angles at angle C and angle F. And the theorem says if a hypotenuse and leg of one triangle are equal to the corresponding parts of another right triangle, then the triangles are congruent. So we're going to take and make the hypotenuse and leg equal in each triangle. So we have AB, that's the hypotenuse, is equal to this hypotenuse. And it says the hypotenuse and leg, so we're going to pick a leg, and I did BC. And it shouldn't be BC. Yeah, BC and EF. So we have just like what the theorem says. We have right triangles, we have a hypotenuse in one to the other, and a leg to a leg. You could have done this leg, it wouldn't have mattered. Now we're going to prove that these two triangles are congruent. We don't have any proof for ASS. So we can't use those letters anytime ever to prove two triangles are congruent. What we have to do this is we have to add parts to our proof. What I'm basically doing is parts to the triangles. So what I'm basically doing is I'm going to take these two triangles and I'm going to stick them together like this. But you can't just do that without reasons. So we're going to come up with some reasons. The first thing I'm going to do is I'm going to take this triangle right here, it's right here, DEF, DEF, so that's right here, and I'm going to draw a line, this line right here, through D and F. And I can totally draw a line through 2 points because we have a theorem that 2 points determine a line. So I just drew the line DG. And I'm going to stop it at G, and I'm going to make DF equal to FG, and I can do that because we have the ruler postulate where I can draw a line a specific length. So I drew this line, this wasn't in the original drawings, I drew this line, and I labeled this point G, and that's going to be the same length as AC. So that's going to be the same length. So I better put, let's put, we don't know that yet, let's put 4 on here. We don't know that yet, I shouldn't put that there. But we know that this is equal to this because I'm drawing this the same length as this. And then I'm going to connect these points E and G. And that's a ruler postulate, I can connect it. So I drew this line and I stopped it so that F and G are the same, is the same length as AC. And then I drew this line, and I can do that because of the ruler postulate. Now here it's going to be tricky for me to try to explain all this, so try to follow along. I'm going to prove that this triangle is congruent to this triangle, and then I'll be able to prove that this triangle is congruent to this triangle. We're not going to do the formal proof, we're just going to talk it through. Please don't stop the video, try to follow along as best as you can. So here we go. We know that this is congruent to this. We're going to try to prove that this triangle is congruent to this triangle. We also know that EF is congruent to BC because that's given right here, EF, BC. So I can make that have 2 spots. We also know that angle 4 is equal to angle C. And the reason that we know that is because they're both right angles. So you would have to say 3 and 4 form a linear pair. Linear pairs add up to 180 degrees. This is a right angle, so therefore this is a right angle. So if you're doing a formal proof, we would have a lot of steps with this proof, but we're just going to talk it through. So now I can say that triangle EFG is congruent to triangle BCA because of side, angle, side. We have side, angle, side, because we know that right angles are equal. Now, what do we do next? Now we know, since the triangles are congruent, we know that BA is congruent to EG. So I'm going to put a little mark there to show that they're congruent. And we know that this is congruent to that. Let's see, what else do we know? We know that angle 2 is congruent to angle A. So we'll put this here. Then, do we know that DE is congruent to E? Let's go up here. We know that AB is congruent to DE, and we know that AB is congruent to this one. So by the transitive property, we know that EG is congruent to DE. Okay, this is complicated. A lot of transitive properties going on. So we have this triangle is congruent to this triangle. we know that this is congruent to, this one's congruent to this one, and this one's congruent to this one. So now we can say opposite angles are equal. So this is the same triangle, so we know that angle 2 is equal to angle D. Hopefully you're following along. It's complicated. Now we can say that, and we know that this triangle, this angle is equal to this angle. So what we're trying to prove here, we have to keep in mind what we're trying to prove. We're trying to prove that ABC is congruent to DEF. We can prove that so we can say that these two triangles are congruent by angle, angle, side, and this triangle is congruent to this triangle, so this triangle is congruent to that triangle. So that's basically how you talk it through, how to get this triangle congruent to this triangle. So a lot of transitive properties. Okay, that's it. We're going to do a couple example problems and we'll be done.